So for the first section, we are going to be talking a little bit more about transformations and how to use them to graph quadratic functions. So a lot of this chapter is going to be dealing with the quadratic function, which we talked a little bit about in chapter 1. That's when you have y equals x squared. And so we went over when you have a quadratic function, you've always got that x squared component. The squared is what makes it quadratic. And when we talked about the parent function, we saw that it kind of was like a curved U or a curved V shape. So this whole chapter spends a lot of time focusing on the quadratic because there's a lot of different ways that we can actually solve quadratic functions. What we're going to work on today is just kind of like graphing quadratic functions. What do they look like when we're graphing them? So the basic shape, like I said, is they look like a curved V or kind of like a U shape. So the parent function, which we talked about in chapter 1, starts at 0, 0, so that point right there in the middle. And then notice that the 2 points, like you've got -2, 4, and 2, 4, and we've got -1, 1, and 1, 1. Those kind of mirror each other. So if you look at the center of the graph, like this y-axis is the center of the graph there, your 2 points are mirror images, like they reflect. So this -1, 1 reflects over to 1, 1, and -2, 4 does the same thing with 2, 4. Quadratic equations should always do that. Like they should have that reflection happening. They should be symmetric on both sides of that middle point. The two main ways to graph a quadratic function are using a table and using transformations. A table is involving like you pick points, you plug it into the function, and you see what you get, and then you graph those points. So sometimes with the table, it's a little bit of like guessing and checking. So it's not always the best method, but we can use it. The other way is using those transformations, and that's what we talked about last chapter. Looking at the function, being able to read it to understand, does it go left, does it go right, up, down, so that we can take the parent function and just push it for the new one. We're going to start by graphing with a table. So your guys' first example says f of x equals x squared minus 4x plus 3. Remember, f of x is just a fancy way that they say y. So this is really saying y equals x squared minus 4x plus 3. In order to help us graph using a table, we want to try to find the middle point. So like on that graph up above, I said the graph started at 0, 0. That was like right in the center. You don't always have that point being 0, 0, and you don't want to just try to grab random points and just kind of try to guess your way through it. There's a thing that we can use to help us find the center, and that center point is called the vertex. Okay, so step 1 here is going to be finding the vertex. And in order to do that, we use this formula, and it says negative b over 2a. You're going to see this equation a lot, so I would stick it in your brain right now. Negative b over 2a. Now, where does b and where does a come from? Okay, so when you guys come back up here and you guys look at that equation, that x squared minus 4x plus 3. Quadratic equations are always written like this. A x squared plus bx plus c. A, b, and c up here, so this a, this b, and this c, those are just numbers. Numbers sitting in that equation. So a number sitting in front of x squared, a number sitting in front of x, and a number attached at the end. So if I'm looking at my function x squared minus 4x plus 3, a would be the number that's sitting in front of x squared. If there's not a number written there, remember there's technically a 1 sitting there. So a would be 1. B would be the number in front of your x. This one says -4 minus 4x, so we have to pull that minus sign with the 4. So b would be -4. And c, just for good measure, we're not going to use it right now, but c is going to be that 3. That's where you get a, b, and c from. So when they're asking you to do negative b over 2a, you're pulling those numbers from that equation up above. So negative b over 2a, you'd have negative, and b is -4. So we're going to have a double negative on the top. All over 2 times a is 1, so 2 times 1. So let's simplify this. If you have a double negative like that, which is common when we're dealing with quadratic functions, it's going to become positive because the negative of a negative changes it to a positive. You probably remember your keep, change rule when you guys were subtracting negatives. So it just does the same thing. It's like a -1 times -4. So that becomes 4 on top. 2 times 1 is 2. We can simplify that down to a 2. This point right here, the whole reason why I did that is because that's the starting of my graph. Like that's my vertex. That means that that's the center. So when I go to make my chart, this is going to be step 2. When I go to make my little XY chart, I'm going to put 2 in the middle. That's why I found that number, because that tells me where's the middle of the graph. Now, to pick other points for your chart, you want to pick some numbers that are going to be smaller and some that are going to be bigger than 2, because that's going to give you the sides of the graph. So a couple numbers smaller would be like 0 and 1, and a couple numbers bigger would be 3 and 4. To fill out the y portion of our chart, we plug it back into the function. So we go back up here to where I have highlighted, and we plug in all those x values in for x there. Okay? I'm going to show you guys a really easy way to do this on your calculator. So what I need you guys to do real quick is either get your calculator out or come grab one of the yellow ones, because the yellow ones have like a function that you can use to actually do this. I believe so, yes. Yeah, but not till like at the very end. So if you have a calculator and you're typing it in kind of the longhand, so I'm going to just go to a different page so I have some room to show you guys this. So let's see here. That equation said x squared minus 4x plus 3. If you have just a regular calculator, what you can do is plug in those points. We're going to start with 0 because 0 is going to be the easy one. I'm going to put in 0 for all those x's. Now you want to make sure that you're putting parentheses around the numbers that you're plugging in because your calculator doesn't understand order of operation, so you have to tell it what to do first. So I always put parenthesis and then my number I'm plugging in, like 0, and then close the parenthesis and then squared. Minus 4, then I would do another parenthesis 0 plus 3. Then you guys are going to hit enter. What number are you guys getting out there? 3. Okay. If you're not getting a 3, check how you entered it. Make sure it looks just like mine. Open and close those parentheses. Okay, make sure that you have them around the numbers that you're plugging in. Now you could do the same thing then, like the next number is a 1. So you could do parentheses 1 squared minus 4 times 1 plus 3. And you can keep doing that for the rest of your chart. So those of you that want to do that way, I would go ahead and start calculating the rest of those numbers. Now if you have a yellow calculator, so if you're borrowing one of mine, let me grab one real quick. If you click on the button that says table, it's going to say at the very top y equals, and underneath it it'll say enter function in x. Okay? To enter your function, you have to use your x key on the calculator. So we're going to do x squared. So if you guys see the x squared button on your yellow calculator, there's a button right underneath it that says x, and then it's got some other letters. You're going to want to click on that x first, and then hit your x squared button, because that'll type it in as x squared for you. Then you'll do minus 4, hit that x button again, plus 3. So it should look exactly like that equation I have written up there in red. Then you'll hit enter. It's going to ask you for a start spot. I would just type in that vertex point, that 2, And it doesn't matter where you really start, because this is just going to calculate for you all the points that are ever on this graph. So the nice thing about this is it does all that plugging in work for you, so you don't have to do all the parentheses. So keep it on step 1. So you're just going to kind of enter through everything until you get to OK and hit enter. And then a table should show up on your guys' calculator. And you should see these points. And you can go up and down through the table to get the rest of your coordinates. So if you go up to 0, you should see 3. And if you go down to 1, what'd you guys get for 1? 0. And then we could keep filling in our chart. So going back here to my chart, back in our notes, we said 0 was at 3, 1 was at 0. Where's 2 at? And 3? And then 4 is at 3 again. Okay, look at those numbers in the Y column. Do you guys see that pattern? That middle number is like the only one that's kind of different when we talk about the Y, because that's the vertex, like I said. That's the center of the graph. The Y's should do that pattern for you because they should be symmetric on both sides of the graph. So that 3, 0, 0, 3. And if I kept looking, like on my yellow calculator here, 5 is at 8, so that means that -1 would be at 8. 6 is at 15, so -2 would be at 15. So I could keep getting more points if I wanted to. After you've gotten all that stuff, you need to graph it. So 0, you go up 3. That's the point 0, 3. 1, 0. And then your vertex is at 2, -1. So right now I have just the left side of my graph up here. Now I'm going to do 3, 0, 4, 3. And you should see those points are reflecting. Like imagine there's this line going down the center of the graph. These are the same distance away from that line. That should always happen. They should mirror each other. Then what I'm going to do is just connect those dots in that curved V shape. They should not be straight lines. You can't connect a straight line for those 3 points. It's not going to work. You're not going to hit all of them. So you need to get that curved shape happening. Okay? Why don't you guys try one here? So I'm going to give you a couple minutes. I want you to try this whole problem. Start by finding your vertex. So do that -b over 2a. And then make your table. If you're still working, that's okay. I just want to make sure you guys got the right vertex so that you're plugging in the right points. Can you guys tell me what you put in for B? What number did you use? Good, -6. So negative B, 6 is your B, and that's positive, so it's -6. What did we put in for A? -1. So this simplifies to -6 over -2. So your vertex should be at 3. So 3 should be in the middle of your guys' graph. Okay? And then you got to pick a couple points above and below that. So I just did 1, 2, 3, 4, and 5. So if you're not finished with your chart, go ahead and finish that now. So for that chart, for 1 you should have gotten -3. 2 should have been 0. 3 is 1. Then you should get another 0 and -3 again. So now let's graph it. Okay, I'll come look at yours in just a second. So do you guys notice how this one is opening down where the last one opened up? Why do you guys think that is? The negative. So the negative in front of x squared is going to cause this graph to flip the other direction. It's going to flip down. If it's not going down, check if as long as you have your points right, check how you graphed it, because you might have just went the wrong way when you graphed it. The last way I want to talk about graphing is using transformations. And we did a little bit of this last chapter where we were looking at functions to figure out which direction is it moving, left, right, up, down. So we're going to be doing a little bit of that again. Now all of these parent functions should be that x squared. So you don't really have to worry about identifying the parent because we know that that's what we're working with, since I said this whole chapter deals with quadratics. So your parent function, remember, is always that y equals x squared. And we'll use that chart that we used last chapter 2 to help us graph the parent function. And then we'll just translate it. Now what we have to do is look at our function here. X plus 2 squared minus 3. Now there's two numbers in here that have changed our parent function. We have the plus 2 that's inside parentheses, and we also have minus 3, which is on the outside. So if you guys think back to last chapter, plus 2 when it's inside parentheses, that makes it move left or right. Which direction is it going? Left or right? Good, left. So this is going to go left 2. What does the minus 3 make it do? Down 3. Remember, inside parentheses like that makes it go left, right, and you have to think backwards. Positive means we're going left, minus means we're going right. If it's on the outside of the parentheses, like that -3 is, that's just going to make it move up or down. So from our parent function, this was from last chapter. I talked about those t-charts. We did those in section 2. I always did that -2, -1, 0, 1, 2. So we're just kind of pulling from what we just talked about. So we can't forget everything that we just did in chapter 1. Remember, this chart was always 4, 1, 0, 1, 4 for those points. That's the parent function. So when you're doing these problems, if it's helpful for you when it comes to graphing, I would graph the parent, and then use those translations, left 2, down 3, to graph the new points. So this prevents you from having to create a new chart or having to plug anything into your calculator. You can just kind of read the graph and understand what's happening. So I'm going to scroll down here and we're going to graph this. So I'm going to graph the parent function first. Okay, so there's the parent. That's using that chart that I wrote down. So now I take all of these and I go left 2, down 3. So at each point, go left 1, 2, and down 1, 2, 3, and draw your new point. And there's your new one. Okay, let's look at the last one. It's on the next page. You do not need to write the points, no. So we've got negative x squared plus 5. So parent is still y equals x squared. Let's talk about what's happening to it. So we have a negative in front of the x, and then we have plus 5. So remember, if x is only negative, back from chapter 3, or section 3 from chapter 1, if x is negative, that's because they reflected over the x-axis. If the whole thing was negative, then it would have been reflected over the y. So we're going to reflect this over the x-axis. What is that plus 5 going to make it do? Good, up 5. So kind of the first movement is that it reflects. Second movement is that it goes up 5. Again, I'm going to use that same t-chart from the last problem because for my parent graph, so that's going to look the same. Okay, hopefully by the end of this chapter, you'll know that graph and that chart just by memory because you'll have done it so many times. All right, so if I graph, I'm going to graph the parent first, so it's going to look exactly like that last problem. Okay. Now, reflecting over the x-axis is the one that goes left to right. It's this one right here. This is the x-axis. So we're reflecting over that, which means that it mirror images itself down underneath the x-axis, and then that point has got to go up 5. So let me show you kind of like the movement here. If I look at that point 2, 4, if I reflect it, that means that it's still at 2, but it's going down 1, 2, 3, 4. So it kind of starts right there. But then I got to move it up 5. So I'm not going to draw a point there. From that point, I'm going to count up 1, 2, 3, 4, 5 and draw my new point. For the negative 1, 1, if I reflect it, it's at negative 1, negative 1. And then I go up 5. Zero, 0, when you reflect it, it's going to stay on the x-axis because it's already on the x-axis, so when it reflects, it's going to stay there. So I just have to move that point up 5. And then you do the same on the other side of the graph, or you can use what you guys know about these quadratics, which is that they mirror each other on either side, and then graph the rest of that in. And again, this one's opening down because we had that negative in front of that x squared, so it's going to cause it to reflect itself upside down.